So, good morning, everybody. My name is Sinead. I'm the CEO of the company, and my colleague Steve is going to co-host and co-present this webinar as our Earth observation team lead. You're very welcome to our webinar about bringing satellite and in-situ data together. So we just have a couple of topics. We've got the agenda here, so you can see myself and Steve on the slide here as our positions, and feel free, we've put our contact details at the end, so feel free to contact either of us if you're interested in having further discussions about this project. So I'm going to start, and then I'm going to hand over to Steve to talk through some of the technical details later on. But we just have a brief housekeeping list to go through. We'll provide you with an overview of the company as a whole, and we'll talk a little bit about the project that we're doing, which is coastal ocean assessment using Earth observation, and it's been funded by the European Space Agency. We'll then give you some examples of the comparisons that we've done between satellite and in-situ data. And then we invite you to ask questions, to share your feedback with us, either online or offline after the presentation. Should only take about half an hour or thereabouts. And yeah, please feel free to ask any questions you might have at the end. So we're recording the webinar, so we'd ask you just keep your microphones muted until the end. Please feel free to ask questions as you go to the chat box during the talk, and short specific questions are always the most useful thing. So if you want to add your name or organisation to your question as well, so we know kind of what kind of context, I suppose, you're asking the question, that's also very helpful. So the company, TechWorks Marine, our entire ethos and vision is to provide robust, reliable, secure marine data. We collect data from buoys. We use our data acquisition system within the buoys and our data transmission system through both GSM and satellite communications to transfer our data back to our data platform. And we also incorporate satellite data as part of the idea to provide you with a very large spatio-temporal overview of your region of interest. So our entire expertise is around end-to-end delivery of data. So we're providing marine data as a service. That includes integrated data buoys, which are real-time enabled. We have our own proprietary data acquisition technology that is installed within the buoys. And we can provide data from a wide range of marine sensors. Our data management and delivery is all done through our CoastEye platform, which I'll talk about a little bit in a minute. But we provide full data management, including quality assurance, calibration of sensors, etc., all provided on our live data portal, CoastEye. On top of the in-situ data that's provided, we provide satellite-based information. So basically combining the in-situ data with the satellite data to give you kind of fully validated information in the region that you're interested in. We also do hydrographic and meta-ocean surveys and equipment sales and rental, but what we're really focusing on here for this project is the integration and the intercomparison between satellite data and the in-situ data. So our CoastEye data analytics platform is our operational platform where we manage all of our data. It's been developed in-house over the past 15-20 years, and we use it to manage and monitor all of our platforms in the ocean. So it's used to visualize both the real-time in-situ data provided by the buoys and the Earth observation data products. So for example, down here on the left, you can see a chlorophyll map from last year, and it's visible on CoastEye. You can then also connect that into the in-situ data that's made available through the data buoys. So we make it easy to compare the Earth observation and the in-situ data, and then also allow you to download the data. So either download the images, download the graphs that we've generated, and download the data for further analysis offline. Over the past 2 to 3 years, we've been developing our CoastEye mini buoy, which is a small portable buoy that can be deployed quite easily. It can be handled by 1 or 2 people, as you can see in the picture here. You can see the buoy deployed in the water here in Dublin Bay, and here, for example, is a much larger buoy than we would use for our normal long-term environmental monitoring. So the buoys are a lot smaller than the sort of traditional oceanographic buoys that are used for data collection. The buoy has been designed for real-time monitoring in both coastal and freshwater environments, so it can be used in most kind of sheltered regions, so lakes, estuaries, off the coast, and is designed to be very low power in nature. So it's battery powered, has the functionality to add solar panels onto it, but the battery can be taken off and recharged overnight, and the battery will last about 20 to 30 days per deployment. So there's a number of flexible input options, so you can add in up to 3 different oceanographic sensors can be deployed onto the buoy. And as you can see, it's quite unobtrusive, so it's useful for kind of discrete sampling, and can provide you with a full monitoring system at much kind of lower cost than the traditional large buoys. So the CoastEO project, which is the coastal Earth observation, coastal ocean assessment and Earth observation, is designed in the following way. So we collect the data from the mini buoys simultaneous with any kind of satellite overpasses. And Steve will talk about how we do this in a little bit more detail. The data then is processed on our CoastEye platform and analysed for intercomparisons. The data then is visualised on our CoastEye platform, so you can see the image here again, and we can provide information then to the end user in terms of alerts if there is an increase in turbidity, or just general reporting. So the idea of the CoastEO project is to be able to provide information to the end user, either around monitoring for looking at a specific area, or being able to quickly deploy mini buoy if there is an incident of some sort where you can track quality of the water very quickly, as opposed to on a large buoy where you would have to plan the deployment. You'd have to use a large vessel to deploy the buoy in the water. This is a much faster kind of turnaround time. So at this point, I'm going to pass over to Steve to talk a little bit about the satellite data and to talk about some of our results from our analysis so far.
Yes, so satellite data is useful for a number of reasons. It can provide data over a far larger geographical area than your typical in-situ measurements or campaigns. So satellites cover areas of up to thousands of square kilometers. They enable you to monitor and assess the current status and changes over time in the environment. So historical records are available going back quite far. So if we take the Landsat series of satellites, for example, have been orbiting in space since the 70s. So we have imagery from those going back 40 odd years or longer. Data can be complex to process, but the information is quite easy to understand and it's intuitive. People can look at a satellite image and know what they're looking at. And it provides a method for measuring compliance, so monitoring activities, permits, license breaches, etc. So for the purpose of this project, we use satellite data from ESA's Copernicus program, specifically data from Sentinel-2 and Sentinel-3 satellites. This data is free to use, it's timely, it's good quality. Sentinel-2 requires multispectral optical imagery at a high spatial resolution of 10 meters per pixel over land and coastal waters. So the image on the right is a Sentinel-2 image of Dublin Bay. The area captured in each Sentinel-2 image is high resolution, but the area is smaller than that of Sentinel-3, which has a larger geographical coverage but lower resolution. So the image on the left is a single Sentinel-3 image which covers the whole country, whereas a Sentinel-2 image would cover only a part of the country. The OLCI instrument on board Sentinel-3 has a 300-meter resolution per pixel, and the sensor is used to do water quality and land monitoring research. So data from each satellite has its advantages and disadvantages depending on what your requirements are. For example, the larger geographical coverage of Sentinel-3 will mean you have a lower pixel resolution, and then vice versa in the case of Sentinel-2. What we wanted to do was validate the in-situ measurements and satellite measurements, and we chose turbidity as the parameter that we were going to study. So in order to compare turbidity measurements from our mini-buoy and from the satellites, it was necessary to spend some months deploying the mini-buoy at times when the satellites were known to be passing over Dublin Bay. So in order to do this effectively, we developed a script to pull satellite overpass information from a website called spectator.earth. They have an API, which we were able to access with a Python script. So Spectator.earth is a website which provides overpass schedules for a number of satellites at any given location on the planet. The script was timed to run automatically every week and then output the data to a spreadsheet which we could check. And then we could use that spreadsheet to guide our mini-buoy deployments. So if the weather was on our side, the mini-buoy was deployed for a period of time before, during, and after each satellite overpass, taking measurements the whole time. Turbidity data was collected during that time and then relayed to our CoastEye system for later analysis. So in terms of the satellite processing side of things, in order to extract the turbidity data from raw satellite imagery, we had to develop a specialized and automated processing chain. So first, the script would download raw imagery from relevant overpass dates from the ESA servers. Some imagery was taken from EU METSAT servers. Then the script would use a Python version of ESA's image processing software called Snap to resample the data in order to ensure that the pixel resolution was correct. The image then was subset to our area of interest, which is Dublin Bay. Subsetting basically just crops the image and removes unnecessary data and reduces the image size for processing. Next, we'd mask out or remove clouds from the image, or remove them from analysis. The land was also masked in this case because we're interested in the sea. The raw imagery then needs to be atmospherically corrected. This process removes the effects of the atmosphere on the reflectance values in the imagery and determines the true surface reflectance values. This atmospheric correction process produces image bands and with the true water-leaving radiances, as well as producing chlorophyll A and total suspended matter concentration images. We then perform a calculation on band 5 of the water leaving radiance to produce a turbidity product. The calculation is there. And then these products, the chlorophyll A, the TSM, and the turbidity, are uploaded to CoastEye for visualization. So this is what the imagery will look like on our CoastEye platform. So on the left is the turbidity product. A user can click on any pixel or any location on the image to see the turbidity value at that location, as well as the lat long, the latitude and longitude of that pixel. You'll see the turbidity values are quite a bit higher, closer to the shore, which is what we would expect, as the water is a bit choppier there, maybe, or shallower, more sediment. And on the right is the chlorophyll A product displayed on CoastEye. So on CoastEye, it's possible to view a time series of a particular measurement. So a point is chosen on the image, and the generate time series button will produce a graph showing the turbidity value at that point in all the other images from different dates. So we observed good agreement between the satellite measurements of turbidity and the buoys. In this example from Dublin Bay, you can see the satellite-derived turbidity product and the location of the mini buoy at the time that that image was taken. The satellite image was taken at 11:36 a.m. and the mini buoy took a coinciding turbidity measurement at exactly the same time. The satellite turbidity measurement at the mini buoy's location was 0.84 NTU, while the buoy measured turbidity at 0.74, so a very small difference between those. Oh, sorry. Sorry, I'm just after losing myself. Sorry. So from August 2019 to July 2021, we processed a total of 85 satellite images for turbidity and had coinciding buoy turbidity measurements for comparison with those images. Many images couldn't be used because of persistent cloud cover in this part of the world. So it does depend on whether there's visibility through the clouds. The mini buoy was deployed from May 2021 to July 2021, with larger buoys were used from August 2019 to June 2020. Overall, we've seen excellent correlation between the satellite and buoy measurements of turbidity. In the right-hand scatter plot, you will see correlation coefficient of 0.88 between all the buoy measurements and the satellite measurements. And in the left scatter plot, you can see a correlation coefficient of 0.98 between the mini buoy and the satellite measurements. While there are fewer mini buoy measurements, the results are promising and indicate that smaller buoys may produce more accurate results when compared with larger buoys. And finally, these are the turbidity measurements of each separate buoy compared with the satellite measurements. It's possible to see good general agreement between the buoys and satellite measurements, as well as seasonal fluctuations in turbidity measurements. Winter months see an increase in turbidity, particularly during November. The mini buoy shows closer agreement with the satellite when compared with the larger buoys. This may be due to the fact that the turbidity sensor on the mini buoy is closer to the surface, and so reflects more accurately what the satellite would be seeing. So in terms of our success criteria, we've developed a specialized satellite processing chain optimized for Sentinel-2 and Sentinel-3 analysis. We've demonstrated turbidity correlation between the satellite and in-situ data. The correlation between the mini buoy data and Sentinel-2 and 3 data was quite high at 0.98. That means that the mini buoy correlation is better than the larger buoys, as mentioned, that the sensor is closer to the surface. And it is actually a better, more high-spec sensor used on the mini buoy. We focused in this study on turbidity, but we could also do the same thing for chlorophyll A, TSM, etc., depending on which sensors are on board. And actually the mini buoy can be deployed with up to 3 sensors, separate sensors on board at one time. So it can be tailored to fit a client's needs and requirements. And this is useful for testing in different local environments. So I'm going to hand you back to Sinead.
Thanks, Steve. So this project is designed to provide a service to our clients, which involves a combination of using our reliable in-situ monitoring to validate the high-resolution satellite data that you have seen, and in the end to provide you with easy to access water quality information, which can be available through the CoastEye portal. We've identified a number of benefits for users of the service. So basically, it can provide a reduction in time and cost around manual sampling. So you don't need to go out and keep sampling constantly. As the buoy can be deployed out in the water for a period of time and will be sending back real-time data consistently, which can be used to validate the satellite data. Being able to provide kind of high quality scientific grade sensors on the smaller buoys can give you high quality information, but can still reduce the cost, because the main cost around buoys in general is the larger buoys are much more expensive to deploy, much more expensive to maintain and service while they're out in the water, whereas a smaller buoy like the mini buoy, it's much easier to deploy it and retrieve it, to clean it or anti-biofoul and put it back in again. And being able to do the analysis to validate the satellite data within the service will then allow the end users to focus on their core competencies. So we're providing the expertise around the satellite data analysis and giving the client the information at the end, so that they don't need to become experts in satellite analysis. It can also enable larger scale monitoring. So if you're looking at small scale manual samples, you can deploy the buoy in a number of different locations over a relatively short sampling campaign. The kind of agglomeration of points and data then can allow us to provide the validated satellite data, and then from then on you can trust the satellite information because it's been validated by in-situ data. Over the long term, it can provide assistance with compliance around reporting under the EU's Water Framework Directive, for example. It can provide evidence of compliance with permits for licenses, so around water quality monitoring in general. And we can provide this basically as an EO service based on international best practice. So to, I suppose, give an overall summary of what we have been doing within the CoastEO project, we've been using this mini buoy, which actually we could fit in this room quite easily. You could bring it up the stairs. It's handled by one person, so you could have it on the stairs, have it in the office, and show to people that's how small it is. So it's small, it's portable and discreet, can be transported in the back of a Jeep or a truck, and deployed using a small boat. The short-term deployments can be used to validate the large-scale satellite data. So as Steve mentioned, the mini buoy does appear to be giving excellent correlation against the satellite data, both Sentinel-2 and Sentinel-3, even over a relatively short measuring period of the summer of this year. And the results are very promising, especially when compared to the bigger buoys in a similar environment. So the buoys that we use the data from 2019 and 2020, are a much larger scale. They're 2-3 meters in diameter, as opposed to the mini buoy, which is about 0.5 meter in diameter. And so the combination of the results is quite consistent. And we're happy to talk to people about looking at chlorophyll or total suspended matter, or any other kind of data that you might have an interest in. One of the things that we're interested in looking at as part of this work in future is to look at oil and water sensors. So, for example, looking at monitoring oil or diesel spills and linking that to both optical information, so from Sentinel 2 and Sentinel 3, but also linking it to radar data, which, as Steve mentioned, we are in a very cloudy environment in Ireland, and using radar data would help to alleviate that, because the radar data is visible through clouds. And so combining the optical and the radar data will actually give an even better overall picture. And so that is our presentation. I'm going to try and see if I can find the chat box here. So we've left our details here. So mine and Steve's emails are here, and our office phone number. You can also follow us on Twitter, TechWorks Marine. But if you have any questions, either if you'd like to put in the chat, or if you'd like to share your video or turn on your microphone, please go ahead. Just make this smaller.
Hi, Sinead. Thank you very much for the presentation. That was fantastic. As I'm with Dunleary Rathdown County Council, and an area we're particularly interested in is bathing water quality. We did work briefly a few years ago with TechWorks Marine on an SBIR. So one of the things that we're still pursuing and still interested in is the idea of proxies that could prove a kind of an early warning system for bathing water quality. Could you talk to me about some of the work that you're doing around that?
Sure. So we're carrying out an unrelated project, which is looking at bathing water quality monitoring in terms of proxies for E. coli. But we've identified that the mini buoy basically can be a really useful tool for short-term monitoring, especially in and around coastal areas. And sort of part, I suppose, of the work that we're doing here was was looking at the validation of satellite data using the mini buoy. And these nice kind of results are indicating that, yeah, we can use the mini buoy to validate the satellite data. And our next steps are going to be to look at other, so as I mentioned there, we're looking at other things like oil and water sensors, but there are also sensors out there which can measure proxies for E. coli as well. That's something that we're interested in exploring. Really the mini buoy, sorry, something reversing in the background, just the close. Because the mini buoy is quite tailored or tailorable, can be used for a number of different sensors. It could be possible to have sensors which are measuring kind of your temperature, pressure, conductivity, plus kind of E. coli indicators together. So if you have a multi-parameter sensor on board, you will end up then getting a whole suite of parameters that you can look at. And basically then the idea is, if the satellite data can be, if there's, if there are equivalent parameters from the satellite data, we can examine both of them. So for example, if you're looking at, plumes from the river, or, freshwater plumes coming into the ocean, that kind of thing, it should be fairly easy to spot that in kind of in optical data, and then also back that up with the mini-buoy data.
Yeah, historically and ongoing, the issue that we have in Dún Laoghaire is that when there's heavy rain in Dublin and there's an overspilling event at Ringsend, then invariably we're going to have poor bathing water quality at Sea Point and possibly at the 40-foot. But at the moment, our way of doing that is to sample and go to the lab and grow a culture. So by the time we've done all of that, it's kind of too late. So it's an area that we're very interested in developing, and I'll certainly follow up with you afterwards to see if we can work on this together. I'd love to get something going there.
Yeah, definitely. And we've also we'll put this webinar up on our YouTube channel afterwards. But we've also run a couple of different webinars, and we had one I think in June, which was kind of covering some of the E. coli work that we're starting on. So, if people are interested, we have kind of been doing a suite of webinars over the past few months around our various topics. So you can always find a bit more information there. But yeah, we're absolutely happy to talk to people.
Great, thanks very much, Ned.
Is there anybody else who has any questions? Okay, well, I'm glad that we were so clear. So yeah, as I said, our contact details are on the slide. So if you're interested in talking to us at all, please do. We're always happy to talk to people. And what we'd really like to learn about, I suppose, from people is there's the specific issues and how we can address them. So that's really what we're trying to do here, is trying to address the problems that are arising around water quality in particular. And we're happy to talk to anybody.
We have a question from Ahmed.
Yes. Oh, thanks, Ahmed. We have, as part of this project, we were looking really at Dublin Bay specifically. We have deployed mini-buoys before in inland freshwater, so in lakes and that kind of thing, as part of our customers have. So there isn't a difference, I suppose, between inland and coastal. We're just more, because we knew we had historical data within Dublin Bay, we knew this was a good opportunity to test, but it's absolutely possible to do the same thing with inland freshwater lakes. It's really around the size of the lake in terms of the satellite data. So the data at the Sentinel-2 is a 10-meter resolution. So if the lake or the river is very small, it's not always possible to pick it up on the satellite data. But if the area is large enough, then yeah, it's absolutely possible to do it with freshwater as well. And someone raised a hand there a second ago. I think it was Connor.
Hi, Sinead. Thanks. Yeah, that was really great presentation. I think there are a lot of applications for this for us with the council as well. Just ballpark, if we were to do a project, obviously there'd be a lot of scoping out and stuff, but ballpark, how much would it cost to deploy one of the mini buoys?
So generally what we do is we would have a kind of I suppose the way the pilot project would work is that we're selling the information, so we're not selling the mini buoy specifically. So it would be the end combination of the service, I suppose.
Okay.
So I can't really give you a ballpark figure right now, but I'll have a think about it and I can come back to you on it.
Yeah, that'd be great. If you could, when you're sharing the link or whatever, if you could maybe just give us a rough ballpark, or we could have a follow-up chat, actually, would probably be best.
Yeah, perfect. Yeah, absolutely.
Thanks.
any other questions? I think that's it. Okay, well, as I said, our details are there. We're recording the webinar, so we'll post it up as well on our YouTube channel. So if anybody would like, please feel free to share it with your colleagues as well. Yeah, please feel free to get in touch with us and we'll be happy to talk to you. So yeah, thank you very much to everybody for attending today, and I hope you have a nice afternoon.
Thank you very much. That was fantastic.
Great. Thanks guys. Talk to you soon.
Thank you. Bye. Bye.